Clearinfra. Efficient by design, intelligent by nature.
Welcome to The Explainer. Today, we're going to talk about the single most important number in building design. It's a number you've probably never even heard of, but trust me, it quietly controls pretty much everything. How much a building costs, how comfortable you are inside it, and its carbon footprint, right from day one. So, have you ever wondered about this? You see these absolutely beautiful, modern, all-glass buildings, right? They're shimmering in the sun. But then you hear that on the inside, they're just an energy nightmare, costing an absolute fortune to keep from turning into a giant greenhouse. Well, the reason for that huge disconnect starts with one super simple, fundamental idea. All right, let's dive into it. The whole answer starts with how a building defends itself. And what's it defending against? The single biggest source of unwanted heat it has to deal with every single day: the sun. So every single building has what's called an envelope. This is its skin, the walls, the roof, the glass. It's the first and, honestly, the most important line of defense. Think of it as the barrier that separates all the chaos of the weather outside from the nice, comfortable environment we all want to be in inside. You know, the easiest way to get this is to think about a thermos. A building with a really great envelope is just like a good thermos. It holds its temperature with hardly any effort. But a building with a bad leaky envelope, that's like a cheap thermos that's always going cold, forcing you to constantly reheat it, or in a building's case, constantly run the AC just to keep up. Okay, so if the envelope is our main defense, then glass is usually its weakest point. I mean, it lets in all that beautiful light we want, but it can also let in a ton of heat we really, really don't want. But here's the thing, that same piece of glass holds the key to winning this fight. And that key is a little number called the SHGC. SHGC. It stands for Solar Heat Gain Coefficient. But look, forget the jargon. All you need to know is it's a number, usually between 0 and 1, that tells you exactly how much of the sun's heat gets through your window. That's it. A lower number means less heat gets in. Just think of it like sunscreen for your building. And this is where it gets really interesting. Check this out. Your average plain old clear glass might have an SHGC of around 0.45. That means it's letting in a whopping 45% of the sun's heat. But a modern high-performance coated glass, that can drop all the way down to 0.23. So with just one smart choice, you've literally cut the solar heat blasting through your windows by almost half. Now, here's the part you really need to get. In warm or hot climates, choosing a low SHGC is the single most powerful thing you can do to control heat. We're talking more effective than just about anything else, even more than packing more insulation into the walls. It gives you the biggest bang for your buck, period. So what happens when you get this wrong? Well, picking a high SHGC at the start of a project isn't just one small mistake. Oh no, it kicks off this massive, costly, and pretty much irreversible chain reaction. It's a domino effect that impacts everything. And every single building follows this exact path. It all starts with the envelope. You get that wrong, you pick a high SHGC glass, and you get a massive thermal load. That's just a fancy way of saying there's a huge amount of heat you have to get rid of. Well, to fight that huge heat load, you have to buy a giant, oversized HVAC system. And that's where your upfront costs and your long-term carbon footprint just explode. Now, you'll hear this all the time in the industry. It's this common belief that, don't worry about the envelope, we'll just fix it with a better, more efficient AC system. The idea is that technology can solve the problem of a bad design. But honestly, that is a complete misunderstanding of basic physics. And here's why. A more efficient machine uses less energy to do a job, which is great for your monthly bills. But, and this is the key, efficiency does not change the size of the job. If your bad envelope creates a mountain of heat to remove, you still need a giant machine to move that mountain. It doesn't matter how efficient it is. You simply cannot out-engineer a bad thermal load. Let's look at a real-world example, an office in Bangalore. With a typical design, the cooling load, the amount of heat the AC has to fight, was 145 watts per square meter. Just by switching to a smarter, low SHGC glass, that load plummeted to 92. That's a 36% drop in the size of the problem before you even switch the AC on. And that huge drop in the cooling load, that is not just some engineering number on a spreadsheet. No way. It has massive direct financial consequences that ripple through the entire project. It literally turns physics into money in your pocket. Because the heat problem you have to solve is over a third smaller, the machine you need to solve it can also be about 30% smaller. And we're not just talking about the main chiller unit. This means smaller ducts, smaller pipes, smaller pumps, less electrical wiring. It's a direct, upfront saving on your capital cost. And this right here is probably the most important takeaway of this whole thing. It completely busts that old myth that green buildings or high-performance buildings always have to cost more. The reality is, when you're smart about it, spending a little bit more on the envelope, on that low SHGC glass, lets you spend way less on all that expensive machinery.
So, how much less? Well, in that same Bangalore office, the savings from downsizing the whole HVAC system were so big that the total cost to build the project actually went down by 8%. Let that sink in. The higher performance building was actually cheaper to build from day one.
And you know what? It gets even better. That slightly higher cost for the better glass, it paid for itself in less than 3 years, just from the lower energy bills. After that, it's pure profit for the rest of the building's life. It is an absolute, undeniable financial win-win. So, what's the lesson in all this? How do you make sure you get this right every time? Well, it's not about making a bunch of random choices and hoping for the best. It's about following the right order of operations, a golden rule for design. You see, all truly high-performance buildings follow this exact sequence. And notice what's right there at the top. Step 1, control the sun. That means making a low SHGC your top priority. Why? Because it has the biggest ripple effect on everything else that comes after it. The rule is simple. Shrink the problem first, then you worry about solving what's left. At the end of the day, it's really this simple. Your money, your comfort, and your carbon footprint will always follow physics, whether you choose to pay attention to it or not. If you respect the physics at the very beginning of a project and choose the right SHGC, all the rewards, the lower costs, the better comfort, the smaller carbon footprint, they just follow automatically. The only real question is, why would anyone ever design any other way?